Well, we are continuing our review of derivatives, and today we are going to be looking at the AP College Board. And if you look at your review study guide sheet, we're going to look at the computation of derivatives. So yesterday we talked about the definition of a derivative. Now we're going to get a little bit better with the actual skill of computing derivatives. So we're going to review such things as a power derivative, exponential, logarithmic, trigonometric, inverse trigonometric. Ooh, do you remember the quotient rule and the product rule? And then good old chain rule and implicit differentiation. Okay, so examples. So the first example here, we're given a lot of facts about the function, and we have to find the derivative of h at 3, and we're told that h of x is the product of f and g. So what we need to do then is we need to use our product rule. And so the product rule states that we take the derivative of the first term, the second term stays the same, and then we add that to the derivative of the second term, and the first term stays the same. Now this is all in terms of 3, okay? So we're going to have the derivative of f at 3, and then we'll have g, the value of g at 3, plus the derivative of g at 3, and then f at 3. And now we'll just use the values that are given to us and substitute it into the equation. So the derivative of f at 3 is 6, and that's multiplied by the value of g at 3, which is 4. Plus the derivative of g at 3 is 5, multiplied the value of f of 3, which is 7. So we end up with 24 plus 35, which gives us a value of 59. Okay? Let's look at another one. So example 2, again, we're given some facts about our function u and v, and first of all, we have to find the product of 10 times uv derivative, and then the quotient. Woohoo! Remember quotient? So let's start with a first of all. With the product rule, we know that we can bring out the coefficient 10, and then take the derivative of the first term times the second term, plus the derivative of the second term times the first term. And then we're going to substitute the values because everything here is in terms of 5. So 10, the derivative of u at 5 is negative 3, and v at 5 is 2, and then the derivative of v at 5 is 6, and the value of u at 5 is 7. And now you just do your mathematics, and let's see, I believe we get 10 times, it's negative 6 plus 42, so negative 6 plus 42 is 36, so we have 360. Okay? Now part B is quotient rule. Oh yeah, you remember it. Low d high minus high d low all over the square of what's below. Woohoo! Okay, so enough of that fun. So the value of v at 5 is 2. The value of the derivative of u at 5 is negative 3. Subtracting the product of u at 5 is 7. The derivative of v at 5 is 6, all over the value of v at 5, which is 2, squared, so that's 4. And then I'll let you simplify that and get the answer. We're just really reviewing the, okay? Now, looking a little bit more at some examples, here we're going to talk about the chain rule, okay? So chain rule, let's switch colors to something more exciting. So we are told, we have to find, the derivative of f at negative 1. And we're told that f has a value of h of g of y. Well, to find the derivative of this function, chain rule says we take the derivative of the outside, and the inside stays the same, and then multiply that by the derivative of the inside. Okay, so now I'm going to substitute the values for what I know, and we know y is negative 1. So we have to take the derivative of g at negative 1. So g at negative 1 is 2. And then the derivative of g at negative 1 is 7. Okay? Now kind of keep that separate because I still, order of operations, now have to take the derivative of h at 2, which is negative 1. So I have negative 1 times 7, which would give me an answer of negative 7. Okay? Let's see, the next one also is just the chain rule. And you know what? I'll let you work that one on your own. So if you do it correctly, you should get an answer of negative 18. Okay. Implicit differentiation. It's been a while since we've seen this topic. So if you're taking a function, you're taking the derivative of both, you have to take the derivative of both sides with respect to x. So now there you go, dy dx. with respect to x. And then you want to collect all the terms together that basically isolate to one side all the dy dx terms. And then you'll factor out the dy dx and solve for dy dx. So if you need to write these steps down, you can pause the video at this point and get those steps down. Let's look at it. So let's say we're given this function. Whoa, my example got a little wacky here. I'll write that function out clearer for you. So the function actually is x squared plus y squared is equal to 16. And I want to write an equation that's tangent to the circle at the point 2, -2. Well, whenever I want to write a tangent line, I know I need two things. I need a slope and I need a point. Well, they give me the point as 2, -2, so that means I need to find the slope, which is the derivative. So then for this function, I'm going to take the derivative in respect to x of both sides, x squared plus y squared, and of 16. Okay, now in doing the math, remember it's in terms of x. So if I take the derivative of x squared in terms of x, we know that to be 2x. And then remember with implicit differentiation, you'll notice here that at this point, the variable x does not match up with this variable. So what we have to do is we take the derivative, which would be 2y, but we say implicitly that this was dy in terms of dx, okay? And then it would be equal to 0. So now I've taken the derivative of both sides. I'm going to isolate the dy dx. So I subtract 2x from both sides, and I get -2x, and I'm going to solve for dy dx, so I'm going to divide by 2y. So I get -2x over 2y, so then it turns out that the derivative is -x over y. Well, I need the slope, and if I use the point 2, -2, then I would have the opposite of 2 divided by a -2. So 2 divided by -2 is -1, and the opposite of that would be 1. So my point-slope equation is y plus 2 is equal to 1 times x minus 2. And remember, you don't have to simplify. You can leave it just like that to save yourself some time. So let's do one more example with implicit differentiation. Okay, so here you notice we're having to take the second derivative of this function. And by looking at the function, we can see that the variables are on both sides of the equation. Okay, so we're going to have to look at it in terms of dx, dy. So I'm going to take the derivative of both sides of the equation, but it's in terms of x. So when I look at the first part, I would get 6x squared, and that's in terms of x, minus 6y dy dx. And the derivative of 8 is 0. Now we want to get the dy dx by itself, so I have -6y dy dx is equal to -6x squared. Divide by -6y, and I would end up with x squared over y is the first derivative. But remember, we need to find the second derivative. So now let's go to the second derivative. And remember this notation? The second derivative, whoops, I made a mistake there. Let's see if I can erase that easily. I can, woohoo. The second derivative of y and dx squared. Okay, so now this is a quotient here. So I need to use a quotient rule. So low, and then the derivative of the high, x squared would just be x, minus high derivative of the denominator would be 1, but remember it's in terms of x, dy dx, all over the square of what's below, y squared. Okay, so for this function then, my goal is to simplify this. Now notice I have a dy dx there. What am I going to do with that? Well, we know that dy dx has a value of x squared over y, so I can substitute that in. So dy dx is x squared over y, all divided by y squared. So we have a complex fraction here. So I'm going to write the numerator out as a fraction. So the common denominator would be y. So this would become a y squared x minus x to the fourth all over y. And then it's divided by y squared, which just means times 1 over y squared. So the result then is y squared x minus x to the fourth all over y cubed. Okay? Let's see. I think that's right. Or did I make a mistake somewhere? Seems like I made a mistake. Oh, darn it. I did. Did you see my mistake? At the very beginning, what's the derivative of x squared? It's not x, it's 2x. I'm so sorry. So this should be a 2x. So this should be a 2x. So I end up with 2 y squared x minus x to the fourth all over y cubed. There we go. That's more like it. Okay, and I think that will be it for today. Now make sure you do your practice, and we'll catch you up next time.